CircuitPython scholars, this is Prof G, and in this video we'll move beyond the circuit playground. I'm going to install CircuitPython on 3 different microcontrollers, an Arduino, a Feather format board, and a QT Py format board, but the concepts learned will also work on other boards. Then we'll identify and install CircuitPython libraries for our board. We'll use the REPL to identify all of the objects and pins that are available on the board that's currently plugged in. We'll write code to blink the built-in LED light that's on most boards, and we'll run the same code across multiple boards. This is a nice first thing to do to make sure that a board is set up and working properly. Then we'll see what happens when we try to run this code on a board that doesn't have an LED object. And we'll leverage what we learned about working with multiple Neopixels on the circuit playground to flash a single Neopixel light that's built into some boards. There's a lot of big learning ahead. Let's code! Now I'm going to start off by installing CircuitPython on an Arduino Nano RP2040 Connect board. Now if you've been following CircuitPython school using the Circuit Playground Bluefruit or CPB, you've already installed CircuitPython on that board. Well, the procedure is pretty much the same for any CircuitPython microcontroller. Raspberry Pis are a bit different, and I've got a video on my channel and a written guide for setting up CircuitPython on the Raspberry Pi if that's what you're looking for. Also, before working with a new board, remember that Adafruit has a Learn Guide for every board they sell. Some boards, like the QT Py that we'll be using, have slightly different methods to get into bootloader installation mode. It's not just a double tap of the reset button, and a quick look at the Learn Guide can save you some frustration. So for the board that I'm about to use, if I search for Adafruit Learn Guide Arduino Nano RP2040 Connect, I find this wonderful guide prepared by Liz Clark, who's on Twitter and Instagram as BlitzCityDIY. She's a great resource to follow, and her guide includes step-by-step installation instructions. Now, if you've installed CircuitPython on a Circuit Playground Bluefruit board, you know what to expect. Head over to circuitpython.org, click Downloads, find your board and select it. Some boards have similar names, so make sure you choose the right board, and since there are hundreds of boards, you can use the search box at the top of the page to narrow down your choices. Then, on your boards page, click on the Download button to download your UF2 file. You can minimize your browser, then plug in your board. On most boards, you then double-tap the Reset button to enter what's called Bootloader Mode. You need to be in Bootloader Mode before we can drag over this UF2 file that we just downloaded. Now, your board should show up on your desktop mounted like a flash drive. And if you've double-pressed the Reset button, it should have a name that's not CircuitPy, something that reflects the name of the board. This Arduino Nano RP2040 board shows up just as RPI-RP2. That's usually the name for a board that uses the RP2040 chip, but if you see a name that's not CircuitPy, then you're in bootloader mode. We're ready to drag over that UF2 file to set the board up to run CircuitPython every time it's turned on. We should only need to do this once per board, or we do it again if we upgrade to a newer version of CircuitPython. Now, once we see we're in bootloader mode with the board mounted on our computer, just drag this .uf2 file that you just downloaded into the board that's mounted on your computer. The file will copy over, the board will dismount and disappear from your computer, but a new volume should show up shortly with the name CircuitPy. Congratulations! You've got CircuitPython on your board. Now, if your board seems to hang or get stuck, you can repeat this procedure, then press reset, and the CircuitPy volume should show up. And if you run into any problems, you can search online for a troubleshooting guide, and you can also post to forums.adafruit.com or use the firm's Discord channel, where there are lots of super smart and super friendly folks ready and willing to help newbies skill up. And as a super quick demo to show you that the procedure is similar for other boards, here I have a Feather RP2040 board. I'll head over to circuitpython.org, click Downloads, search for Feather RP2040, select that board and click Download to get that board's UF2 file. It's important that you get the specific UF2 file for each board. These UF2 files do vary by board. Now while I'm here, I'll also search for and download the file for the QT Py RP2040 board, since I'm going to install CircuitPython on that board too. And with the Feather RP2040, this is an example as to why it's important to visit the Learn Guide. You can see the installation instructions here aren't to double-click on the Reset button. To enter bootloader mode, you have to hold down the Boot Cell button that's highlighted here in red, and while you continue to hold that down, then you press the Reset button, which is in blue. And if I follow these steps, I can see that the board mounts in bootloader mode. This board also mounts as RPI-RP2 when it's in bootloader mode. But I can now select the UF2 file that I downloaded for the Feather. I'll be sure to pick the right one since these 3 files are different. I'll drag it into my board. The file will copy over, the board will dismount, then it'll remount, and it'll be named CircuitPy. I've got CircuitPython on that board. And for the tiny but powerful QT Py RP2040, check the Learn Guide. This one also has a 2-button bootloader procedure where we press and hold Boot Cell while we press and release the Reset button. So I'll do that. The board also mounts as RPI-RP2. I'll drag over the correct UF2 file. After it copies over, the board dismounts, remounts. CircuitPython is on that board too. So these procedures should be more or less the same for any microcontroller board, unless you're using a computer with an operating system like a Raspberry Pi. Just be sure to consult the Learn Guide first in case there are any changes in the procedure. Now we need to download the CircuitPython libraries for the version of CircuitPython that we're using. And while we install the base version of CircuitPython, there are also dozens of libraries that extend the CircuitPython language so we can use all sorts of additional hardware and take advantage of pre-built code. Now the reason these libraries aren't built into the base CircuitPython is that they take up too much room on the board. Now to get to the libraries, we head back to circuitpython.org. This time we're going to click on the Libraries tab at the top. Then we'll scroll and find the link to download the libraries for the version of CircuitPython installed on your board. Now in this video, I just installed CircuitPython 7, but if you're using a different version of CircuitPython, just make sure that you're downloading the libraries that match the version on the UF2 file that you just installed. Then you can minimize your browser, and you don't need the UF2 files anymore. I'm going to just throw the 3 that I downloaded into the trash. And then let's take a look at the folder that we just downloaded. Now inside here, you'll see a folder named Examples. And if you open this up, there are all sorts of code examples that show you how to use the various CircuitPython libraries. Exploring this is a great way to learn, and it's also a great way to get starter code for projects that might use a particular library. But let's head back, and we'll open up the folder named lib, L-I-B. Now this folder contains all of the libraries available in CircuitPython, more than we want. So what we're going to do is to select a subset of libraries that we're likely to use in our series. And if we miss any, we can always install them later. So to install these, I'm going to head back to the desktop and I'm going to create a new folder, and I'm going to name this lowercase lib, and then I'll find each of the libraries that I need and I'll copy these into the empty lib folder, and then when I'm done, I'm going to copy this new folder with just the libraries I need onto my board, and I'll have the stuff that I need for future lessons. Now I'm going to speed up the video since not everybody watching this video is going to need all of these libraries, but for my students, here's what you need to copy. Adafruit_LED_animation and Neopixel.mpy, which we're going to use to work with Neopixel lights. You'll need simpleio.mpy, which we're going to use when we work with audio. To work with Wi-Fi in the Arduino Nano RP2040 Connect, we'll use Adafruit_ESP32 SPI and Adafruit_requests. You've also got a proximity gesture and color sensor, and for that you'll need Adafruit_APDS9960. Now to work with a gyroscope and accelerometer that are built into the Arduino Nano RP2040 Connect, you'll need Adafruit_LSM6DS. You've also got a temperature sensor that needs the Adafruit_MCP9808. For working with servos, we'll use Adafruit_motor, and you've also got a 12-pad capacitive touch board, which uses the Adafruit_MPR121 library. So at this point, my students should have an LIB folder that they created with 5 folders and 5.mpy files. Then plug in your board, grab the LIB folder that you've just created that has these libraries you need, drag it into the board. You can overwrite any existing LIB folder that might be in there. There might not be any. And when that copy's over, we're ready for our next few lessons. Now, while I'm not showing this on the video, I've also copied over this same folder onto the Feather and QT Py boards that I set up earlier in this video. While UF2 files are specific to each board and can't be shared between boards, the libraries are interchangeable, and the same libraries can be used on all boards running that version of CircuitPython. Now, when I did this, I also copied over some libraries that these boards will never use because the other 2 boards don't have the same features as the Arduino Nano RP2040. So those other 2 boards don't have Wi-Fi, an accelerometer, or a microphone, but that's okay. The files that I copied over will just take up a little bit more space on the boards, but they won't do any harm. So let's find out more about our boards. First, we'll use the REPL to find out more info about our specific board, and then we'll write our first program on that board. First, if you haven't already done the earlier videos in CircuitPython school, we work with a Python editor called Moo. If you need it, you can download it for free at the URL codewith.moo. Just click on the download link, download the version for your computer, and you can also consult the tutorials on this site if you need any extra help. Just remember we're using CircuitPython and not any of the other versions of Python. Now with our board plugged in and CircuitPython installed, I'm going to open up Moo. I'm going to click on the Serial button to open the Serial console. I'm going to drag this window up to give me some more room, and I'll press any key to get into the REPL. And we immediately see the version of CircuitPython and the board that we're using. I'm using CircuitPython 7.0 on an Arduino Nano RP2040 Connect. Now, if you've ever used a text-based system before, one of the first things that you might learn to do is to type in help. So I'm going to give that a shot right now, and when I do, I see that help is a function, Well, in earlier lessons, we learned that functions have parentheses after them. Let's try that out. Help, open and close parens, and we get a URL to visit more Adafruit Learn guides, but we can also list built-in modules with this command here, help modules. So why don't we try that out? And wow, will you look at that? All of these modules are in CircuitPython by default, even without copying over any lib files. Now we see a bunch that we've used in earlier videos. There's board, which we've imported and used in almost all the code we've written so far. We've also used digital I/O, analog I/O, random. Here's math, which we used in an earlier video too. Well, that's neat. And now here's another really useful command. To get specific information about the objects and pins that are available in the board that's currently plugged in, we can enter dir and then in parentheses board. But watch what happens here. When I press this, I get an error that says name board is undefined. Remember why we might get that? First, we have to import the board library in the REPL. Then we can do dir and then pass in board. And wow, will you look at that? There are all of these names that are predefined whenever we use the board library, specifically when we're using the Arduino Nano RP2040 Connect in CircuitPython. Now, some things to pay attention to. We're going to be working with I2C. We'd mentioned in an earlier video that's a communication protocol for some of the devices that we'll plug in. That protocol uses two special pins, SCL and SDA. Remember, the pins or the pinholes that we'll have on this board are similar to the pads that we had on our circuit playground. So there are board objects for those. There are board objects for the built-in microphone. We see a few for those. We'll use those when we work with a microphone. Now, there's also some stuff that we don't see in here. When we worked with our circuit playground, we dealt with board.neopixel, for example, but there's no Neopixel in here because there are no Neopixel LED lights on this board. Now, there is an LED object. Board.LED would be how we access this, and we'll learn how to use that in just a minute. But to show you how this output can vary according to boards, I've got this slide here that shows you the output for the Arduino Nano RP2040 Connect, but here's what you'd see with the dir board command for the Circuit Playground Bluefruit, the Feather RP2040, or the QT Py RP2040. And if we take a look at the output for the Circuit Playground Bluefruit, we can see a bunch of the objects that are built into this board, and many of these we've used. So this board has a button A and a button B. We've used that. It's got an accelerometer, so there are accelerometer objects. Here's the speaker, which we've used. Here are the names for the pins, so there's A1 through A6. Now there's no A7, but remember we work with TX when we work with capacitive touch. So feel free to go back and plug your CPB in and check this out if you want to see some of the things that are available. Now also notice that the CPB also has an LED. Now that's a tiny red light that's on the board. We never worked with it, but we could have by referencing board.led. And if we look below that, we've got the Feather RP2040. This one has one Neopixel built into it, and it also has an LED object. And if we look at the ultra tiny QT Py, in fact, it's so small that it doesn't even have an LED light or an LED object. So this is very cool. Import board, then dir board will show us the names of the pins and objects that we can access from our board library. This is very handy. It's often the first thing you'll want to do whenever you work with a new board. But now let's use that LED object that we saw, and we'll write a bit of code to flash that LED light, and then I'll install the same code on different boards, and we should see that the code works on all boards that have an LED. So let's head back to Moo, we'll close the serial console, and this will be our blink code. And if you've gone through the previous CircuitPython school tutorials for the Circuit Playground Bluefruit, you should be able to understand the code we're about to write. We're going to import board, time, digital I/O, then we're going to set up an LED object. We'll call that LED, and we'll say equal digital I/O.D digital, I in, O out, and in parentheses we're going to pass in board dot and in all caps LED. That's that LED object that we found when we did our dir board command from the REPL. Then we'll say LED.direction equals digital I/O.D direction dot output in all caps. Then our while true loop will say LED.value equals true. That will turn the light on. Then time sleep. We'll pass in 0.25 to wait a quarter of a second. Then LED.value equals false. That's going to turn the LED light off. Then we'll time sleep for another quarter of a second. Then with our Arduino plugged in, let's save, take a look at our board, and look at that. This little tiny light right here is flashing on and off at a quarter a second, each on and each off. Nice! Now for a true test of the technical amazingness that is CircuitPython and its cross-board compatibility, let's unplug the Arduino board, plug in a Circuit Playground Bluefruit, save that to the CPB, And look at that. This LED that we might not even have noticed before is also flashing, since the CPB also has an LED object on that board that's associated with this particular light. The code that we wrote works here too. Nice! So then let's unplug our CPB. When we do that, we lose our connection. The serial monitor closes, but we can close out of this. Then when we plug in our Feather board, open up the console, we can double click and save the code to the Feather board, and look at that. Our LED light is flashing on the Feather board too. This code works on 3 separate boards. That is the magnificence of CircuitPython. Feel the power of your code skills. Now let's try the QT Py RP2040 board. We'll encounter a problem. Can you guess what it's going to be? We unplug the board, the serial console closes, plug in the QT Py, then save our code to the QT Py. Nothing happens on the QT Py, but if we expand the serial console, we see an error. Oh, the module has no object LED. Now remember, when we compared output from the dir board command and the REPL between the 4 different boards, remember this slide? The QT Py did not have an LED object. Well, that's why we're getting an error. So be aware, when you import board, the library knows exactly what's available for your board. And if you try to use an object that isn't available on your board, your code will crash. But if we look back at the dir board output, we can see that the QT Py RP2040 does have a Neopixel object. So let's save this code to our CircuitPython school folder as Blink, so we have it handy to use in the future. And then let's return to our code, save this back to our QT Py board as code.py, and let's modify it to flash a red, then blue Neopixel light. Can we use concepts that we learned when working with a CPB, even though this is a QT Py board and not a Circuit Playground Bluefruit? Why yes, Code Monster, we can! Setup is going to work the exact same way as we did when we worked with the CPB, although that board had 10 Neopixel lights and this one only has 1 Neopixel light. So first we want to make sure that we import the Neopixel library. Then I'm going to highlight and delete these 2 lines that deal with the LED object, since we don't have that object. And instead we'll create a Neopixel object the same way we did before. Why don't we call this pixel just like we did before? We'll set pixel equal to Neopixel dot capital N Neo capital P pixel, and then in parentheses we'll say board.neopixel. Remember, the board library for the QT Py RP2040 has a Neopixel object, but we only have one. So we'll say comma 1, then comma brightness equals 0.5, comma auto underscore right equals true. Again, the same setup that we did when working with the CPB's 10 Neopixels. We just have 1 Neopixel here. Then down in the while true loop, I'm going to get rid of these 2 statements that deal with the LED value, and I'm going to replace them with pixel.fill, first with open parens, 255, 0, 0. That will turn the Neopixel red. Then I'm going to copy this line, paste it down below over the old LED line, and I'm going to make sure that this is a pixel fill, but this time it'll be 0, 0, 255, setting the light to blue. Then let's go ahead and save. And holy smokes, will you look at that? The light is flashing from red to blue. We indeed have a Neopixel on our QT Py, and it's working just like the 10 Neopixels on our CPB. Code Monster, you are leveraging the CircuitPython skills you learned on one board across multiple boards. You should feel your cross-platform power. Keep at it. There's more goodness to come.